All right, so talking about domain and ranges, we're going to now describe the domain and range of a rational function. Okay, so first of all, let's describe what a rational function is. So a rational function is defined as the ratio of two different functions. So we're going to describe h of x as a rational function, and that's equal to the division of f of x by g of x, where f of x and g of x can be any kind of function. Usually in high school mathematics, we usually see f of x and g of x as polynomial functions, but they can be anything. Okay, so they're asking us to find and define the domain and range of a rational function. All right, so in the last case, we saw that the domain was restricted to all values of x that are greater to 0. In this case, the domain is restricted to a different set of values. Okay, so this has to do with limits, but we have to realize that the denominator function can never be equal to 0, because anything divided by 0 will be undefined. Okay, so in this case, the domain. Okay, the domain will be x belongs to any real number except for x except for values x where g of x is equal to 0. Let me just write g of x equal to 0. Okay, so that's the domain. Okay, so whatever values of x that make g of x equal to 0 cannot be within our domain. Okay, so the range is a little bit more difficult, but we can find the range by finding the inverse function and defining its domain. And by defining its domain, we can find the range. Okay, so let's look at an example here. So the junior tutor gave us an example of f of x equals to 1 over x. So this is our typical reciprocal function here. Our function in the numerator is 1 and our denominator is 1 over x. Okay, so if we were to graph this, the junior tutor shows here that our function is not defined at 0. Okay, and this is because when x equals 0, is 1 divided by 0, and that's an undefined value. And you can see here it has to do something with limits. So as you approach the left side from the left side towards 0, you see here that our function tends towards negative infinity. But as you approach from the right side, our function tends towards positive infinity. And because of this disconnect here, we have to say that this part of the function is undefined, and that means that x cannot equal to 0. Okay, so the domain for this is going to be x such that x belongs to all real numbers except x cannot equal to 0. Okay, so let's look at what our range is. So our range in this case, as we look at the function visually, is that on both sides of the functions, they tend towards negative infinity, and on this side they tend towards positive infinity. But as x increases on the negative axis and on the positive axis, it tends towards 0. But however, it will never actually hit 0. So we can say with confidence that the range of this function is all real values except for y equal to 0. Okay? It's going to tend towards 0, but it'll never equal 0. Okay? So you can see here, by visually graphing it, we're able to ascertain the domain and the range. Okay? So other than that, the solution is correct. So in other questions, because this was a very simple one, if you want to find a domain and range of a function, to find a domain, all you really need to do is to set the denominator function, our g of x to equal to 0 and solve for the values of x that equal to 0. Once you find those values, you know that they are excluded with outside of the domain. Okay, and with the range, you can either graph it, or you can find an inverse function, or you can use mathematical logic to reason out what are the values that are not included in the range. Usually that means that the asymptotes are not included. In this case, in our example, the asymptotes of f of x is 0. So the asymptotes are not included. Okay, so this solution is correct. Good stuff. All right, let's move on to question number 5.